Let us now take a look at the properties of a triangle. Especially right triangles, so a triangle with one of its angles equal to 90 degrees, they play an important role in trigonometry. So we will first look at the trigonometry of right angles. So assume we have a triangle and one of the angles equals 90 degrees. So we have a triangle like this with one right angle. In this triangle, we usually call the tip for the angle where we are looking at O. So here, this is the angle alpha that we will be interested in. The point is O, and then the other points we often indicate with letters P and Q. In this triangle, we have different names for the sides. So we are looking at the angle alpha. The side opposite of alpha is of course the opposite side. This one here is the adjacent side. And the long one is called the hypotenuse. Hypotenuse. So let's make some room here. And then let us add the unit circle to this picture. So here, this is with O the center. This is a radius of 1, and we add the unit circle to the triangle. Something like this. Let's call this point P prime. And if we pull a line down straight, let's call this point Q prime. What we then see is that the triangles OP and Q, so the triangle OP and Q, and also the triangle OP prime and Q prime, they are similar. So we know that in this case that the corresponding sides have the same proportion. Or if we want to put it in a formula, then we can say that the length of the side OP divided by the length of the side OP prime is equal to the length of the side OQ divided by the length of the side OQ prime is equal to the length of the side PQ divided by the length of the side P prime Q prime. So if we then take a closer look at the point P prime, what are the coordinates? The coordinates of P prime, since it's on the unit circle, are in this case the cosine of alpha, and the y-coordinate is equal to the sine of alpha. This is what we saw before. In the unit circle, a point on the unit circle has x-coordinate cosine of the angle it forms with the x-axis, and then the y-coordinate is the sine of the angle. Hence, sine alpha equals the distance from P prime to Q prime. So it's the distance of the side, or the length of the side P prime Q prime. We can then say this is P prime Q prime divided by OP prime. Why? Because OP prime is just the radius of the unit circle, so it's 1. And then if we use the formula below, so the corresponding sides have the same proportion, this is the same as PQ divided by OP, or it is the opposite side divided by the hypotenuse. Similarly for cosine alpha is O to Q prime, so it's the length of the side OQ prime, which is again OQ prime divided by OP prime, because that one is 1. And then we go to the larger triangle. We know that this fraction is the same as the fraction OQ divided by OP, and so this is the adjacent side divided by the hypotenuse. And then the tangent is just sine divided by cosine. Tangent of alpha is sine alpha divided by cosine alpha, and so this becomes the opposite side divided by the adjacent side. So we see that if we have a triangle, we can calculate the angle or the trigonometric functions of the angle based on the length of the sides. For the sine, you divide the length of the opposite side by the hypotenuse, the cosine the adjacent side by the hypotenuse, and then the tangent is the opposite side divided by the adjacent side. This makes it possible to find the values for trigonometric functions using the sides of a right triangle. So, for example, let's say we have a triangle, a right-angled triangle, like this. We have the hypotenuse equal to 4, this side is equal to 3, and call this angle alpha. What we then want to find, what we are looking for, are the trigonometric functions of alpha. So we want to know sine alpha, cosine alpha, and tangent alpha. So these three we have to find. To do this, the first step, or the first thing that we need, is we have to find this side. So what is the length of the side here? Let's call it x. And to find x, we just use the Pythagorean theorem. So the Pythagorean theorem tells me that 3 squared plus x squared equals 4 squared. Or if we rework this, we get that x will be equal to the square root of 7. Now that we know all of the sides, it's very easy to find sine, cosine, and tangent, because we saw sine alpha. Sine alpha was the opposite divided by the hypotenuse, so it's the square root of 7 divided by 4. Cosine alpha was the adjacent one, so it becomes 3 divided by hypotenuse is 4. And the tangent of alpha is then just square root of 7 divided by 3. For the second example, again, take a right-angled triangle. The things we know for this one is this side has length of 12, the angle is 30 degrees, and then we want to find the length of the sides, so call them A and B. How to solve this? What you know is that sine of 30 degrees, again, is the opposite, so it's A divided by the hypotenuse of 12. You know the cosine of 30 degrees is B divided by 12. And you also know the values for the sine and the cosine. So the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 divided by 2. And so you find easily that A is 12 divided by 2, so it's 6. And B is 6 times the square root of 3. We can also use these formulas in a more applied setting. So let's assume that there is a tree. And the tree casts a shadow. So it casts a shadow of length 150 meters. The question is to find the height of the tree if you know that the height of the elevation of the sun is 25 degrees. So in this case, it's not as straightforward. You get a problem which is wrapped into some text and you have to extract the mathematical problem from it. So the best thing to do is first make a sketch, a schematic overview, so you visualize what you are looking for. In this case, we know there is a tree. And we know that the sun casts a shadow. So we have the sun somewhere. And the sun will cast a shadow. The shadow will go through the top of the tree, like this. And then the shadow will be this entire part. So this is the shadow cast by the tree. So we see again that we here have a right-angled triangle, if we assume that the tree is of course growing up, right? And so what we will do is we will name those things. What do we know? We know the height of elevation of the sun is 25 degrees. This means that if you look from the ground to the sun, this angle is 25 degrees. So we are looking up towards the sun, and we know this angle is 25 degrees. And we also know that the shadow has a length of 150 meters. What we now are looking for is h, the height of the tree. So this one we want to find. So the sides that are involved here are the opposite side of the angle and the adjacent side of the angle. So we will be using a tangent. Tangent, so we see that the tangent of 25 degrees is the opposite, h, divided by the adjacent, 150 meters. And so the height of the tree, h, is the tangent of 25 degrees times 150 meters, which is approximately 70 meters. We will come back later to this type of problems, but first we will have a look at the properties of triangles which are not necessarily right-angled.